Okay, for what we have regarding the end behavior of the graph of a function, and we'll be looking at how the function is going to move vertically at the far ends, okay, to the far left and to the far right. And now, don't let the theoretical notation overwhelm you. Okay, we're going to be looking into some applications. Now we have for the readout, okay, we have for a polynomial function of the form whereupon we have f of x is equal to a of n, x to the n plus a of n minus 1, x to the n minus 1, all the way up to the constant a naught. Okay, we have with the characters, okay, the leading coefficient that you have a with the subscript of n. This is going to be in reference to the leading coefficient, or what is often referred to as the coefficient of the highest degree term. And we have for the superscripted n, okay, as an x raised to the n power, okay, that is going to be in reference to the degree of the function. And now for the n behaviors, now we're going to have possibilities here. And for the combination of what we have between the leading coefficient intertwined with the degree to which the function is raised, which will lead to the n behavior. We have in the first case, we have for a of n, whenever the coefficient is positive and n is an odd power, the n behavior is going to be where we have at the far left, the graph is going to be moving down or falling to the left, and to the right we have moving upward. And whenever the leading coefficient is negative and the degree of the function is odd, the n behavior is going to be the polar opposite, where we have moving up to the left and down to the right. Now, as for what we have for even-powered functions, if we had the leading coefficient to be positive, while, once again, n is an even value, the n behavior you're going to have going in the same direction at both ends, whereupon we have up to the left and up to the right. Now, for what we have whenever a of n is negative, while n is even, the n behavior is going to be down to the left as well as down to the right. Now, we have just as a case of what we have regarding n behavior. So we have for the first function, we have f of x is equal to 3x to the fourth plus 2x plus 1. Now, the highest degree term is going to be 3x to the fourth. So the 3 is going to be in reference to the leading coefficient, and that is a positive value. And the degree n, okay, we have to be 4, so that is an even value. So if you notice, we have a positive leading coefficient, and the degree is even. And if you notice in the combination, whenever you have a positive coefficient and even, notice what we have in red in the guideline here. So we have the n behavior have up to the left and up to the right. And so we have for this function, again, you have up to the left as well as up to the right. And in looking at taking what we have here, and just a quick graphical display, and if you notice, okay, we have in behavior, we have moving up to the left as well as up to the right. Now, another function, and we have f of x equals negative 4x to the fifth plus 7x squared minus 5. Now, the leading coefficient, okay, we had to be at negative 4, and that is a negative value, and the power of the expression, okay, that is defined by the highest degree, so that is going to be at 5. So you have a negative leading coefficient, and the degree is odd. And for the n behavior, just to repeat, okay, so you have a negative leading coefficient, the power is odd, so you have up to the left and down to the right. Again, so you have up to the left and down to the right. And a graphical display of this function, if you notice, you have at the far ends, we have up to the left and down to the right. Okay. Now, we have for polynomial functions. Now, these first two cases had the polynomials in fully expanded form. But now for the cases whereupon we have factored form instead, we have for polynomials that are given in factored form, where n is equal to the sum of all the degrees among the factors, and a of n is going to be the product of all leading coefficients among the factors. And I'll show you a bit of a shortcut approach in the process. But just to give you a bit of an intro, now we have determining n, a of n, and the end behavior of the following. And we have for this function, now we have in factored form, we have f of x is equal to negative 2 times the quantity of x minus 2 raised to the third times the quantity of x plus 4 raised to the second. Now for the degree n, okay, you have for the powers of the x terms, you have x which is raised to the third, x which is raised to the second. So you have the degrees of 3 and 2, and for the sum in this case, okay, we have the degree of the polynomial is going to be 5, which is an odd value. And as for the leading coefficient, again, you're looking at the product of all leading coefficients among the factors. So you have negative 2 leading coefficient from x. We have 1 from x plus 4. I have 1 multiplied together. And we have the product to be negative 2. So you have odd power, negative. And for the end behavior, we have up to the left and down to the right. And just illustration here. So we have with the end behavior, we have up to the left and down to the right. Now, in terms of a bit of a shortcut or providing clarification in terms of identifying the leading coefficient as well as the degree and the resulting end behavior, let's say you have f of x is equal to 4 times the quantity of negative 2x plus 3 raised to the second. And then we have times the quantity of 4x minus 7x squared raised to the third. Okay, now we have some different dynamics that will be played out. And if we go ahead and identify the highest degree term, okay, now I don't think we want to multiply literally 4 and then write in expanded form negative 2x plus 3 and then multiply by the cube of this difference of variable expressions. But we need the highest degree term. And in developing, so you have from the first factor, we had the constant 4. And then for negative 2x plus 3 squared, okay, now we don't have to square out all of negative 2x plus 3. We just need the higher order term, in this case, which is going to be, negative 2x, and that's going to be raised to the second. Now for the difference between 4x and 7x squared, notice inside the parentheses, negative 7x squared is the higher order term. And in developing the highest degree term, we have negative 7x squared. And not only that, but the cube of this. So we got 4, square root of negative 2x becomes 4x squared. And for the cube of negative 7x squared, that's going to be negative 343x to the 6th. And multiplying everything out, you got 4 times negative 343, which will be negative 5488. And we have x squared times x to the 6th, which will be x to the 8th. So the highest degree term is going to be negative 5488 x to the 8th. And so we have the leading coefficient is minus 5488. So that is going to be a negative. And for the degree of the function, okay, your highest degree term, again, is of 8th degree. So we have n is equal to 8. And again, the power is even. And again, whenever the leading coefficient is negative and the power is even, we have for the end behavior, we have moving down to the left and down to the right. And we have for this resulting end behavior. Notice that to the far left, you had the graph is moving downward. And to the far right, okay, the graph is also moving downward. So that is what I'm referring to regarding the end behavior, especially in this case, down to the left and also down to the right. Now, tying in together what we have with the zeros, multiplicities, the behavior of the graph in terms of crossing or touching the x-axis, as well as the end behavior. And if we take in factored form, so we have f of x equals 2x squared times the quantity of x minus 3 times the square of x plus 4. Now, if we look for the zeros, the multiplicities of those zeros, and in terms of where the function is going to cross and touch the x-axis, and then we have in the overall picture at the far end where we're going to have for the behavior of the function to the far left and to the far right. So just working with this one function. And now, if you notice, we have with our variable factors, we got x or 2x, and if I set this equal to 0, x is equal to 0. For x minus 3, if I set this equal to 0, x is equal to 3. And for x plus 4, if I set this equal to 0, I have x is equal to negative 4. For the multiplicities, again, we're going back to the degrees of the expressions. So 0 originates from x, which is raised to the second. So 0 has a multiplicity of 2. X equals 3 comes from x minus 3. There's no explicit power, and so we have first degree. And so we have x equals 3 is going to have a multiplicity of 1. As for x equals negative 4, this stems from the square of x plus 4. So negative 4 is going to have a multiplicity of 2. And again, wherever we have even multiplicities, this is where the graph is going to touch the x-axis. So you will have touching the x-axis at x is equal to 0 and x equals negative 4. And since x equals 3 has an odd multiplicity value, it is at x equals 3 that the graph of f of x is going to cross the x-axis. And in terms of what we have, again, working with the same function and trying to figure out what the highest order term is so we can conclude just what the end behavior is going to wind up becoming. Again, we have with the highest order terms, okay, so you have for each factor, so I have 2x squared as a standalone at the front. For the difference between x and 3, okay, we have x is the higher order term, and for x plus 4, okay, x is the higher order term. So we got 2x squared times x, and with x plus 4, again, x, they have the higher order term, and the last factor was squared, so we're going to take this portion and square out. So we got 2x squared from the first factor. Second factor, again, we have x, and with the last factor we have what's going to result as x squared. And if I multiply all together, we have with 2x squared times x squared, you got 2. X squared times x is x cubed, multiplied by x squared, so I have x to the 5th. So the highest order term becomes 2x to the 5th. So our leading coefficient, a of n, is equal to 2, which will be a positive value. And for n, this is equal to 5, and this will be an odd value. So you got leading coefficient is positive, and the power is an odd value. So we have with the end behavior, whenever you have a positive leading coefficient and an odd-powered function, we have, for the motion, you have down to the left and up to the right. So in looking at what we have in the big picture, again, we have with the end behavior, okay, you have down to the left and up to the right. And for the zeros we looked at, okay, now we have with negative 4, again, you have touching the x-axis but not crossing. So we start out below, you have touch, remain below, and once we get to x is equal to 0, again, 0 had an even valued multiplicity, so again the graph is going to touch the x-axis, and so we remain below until we get to x is equal to 3, and 3 again had an odd valued multiplicity, so it was at that location that the graph is going to cross the x-axis. And so we have going from below to above the x-axis. And again, just repeating, we have the end behavior. We have to the far left, you have moving down or falling. And to the far right, we have rising or moving upward.